Hey everyone, and welcome to This Explainer. I'm going to be your studio mentor today, setting you up for absolute success on your very first hardware project. If you've ever stared at a messy tangle of wires and felt just totally overwhelmed, don't worry. We are going to break down the fundamentals so clearly that you'll be building circuits with total confidence in no time. All right, let's just jump right in. We're tackling the two biggest hurdles for beginners today: understanding the mysterious breadboard and decoding those tiny, colorful resistor bands. Honestly, these two elements are the absolute bedrock of electronic prototyping. Mastering them is literally the difference between a circuit that works perfectly on the first try and an afternoon spent frustrated by a dead LED. So let's crack the code together right now. Before you plug in a single wire, we really need to understand our canvas, which is the breadboard. Basically, it's a plug board used for temporary prototypes. And its absolute greatest superpower? It requires zero soldering. None. You just push your component legs right into the grid of holes, and they get gripped by these internal metal spring clips. It makes breadboards absolutely perfect for experimenting, because you can pull a component out and reposition it as much as you want. Now, imagine looking at an X-ray of your board. You'd see these hidden metal strips underneath the plastic that are actually making your electrical connections. It's like a giant puzzle that suddenly clicks when you realize these holes aren't independent at all. They're joined underneath by these hidden metal tracks. If you can picture those metallic strips in your mind every time you look at the plastic grid, the breadboard stops being this mysterious puzzle and becomes a really logical map. So, it's essential to get the difference between the two main types of tracks here. On the outer edges, you have the power rails. Think of these as long power highways running vertically down the sides of the board. They supply your positive voltage and your ground. Then right in the large central block, you have your component rows. These are more like short local streets. They're joined in short horizontal strips of exactly 5 holes. Each group of 5 is a single electrical point, meaning anything plugged into those 5 specific holes is physically connected together. Now, you might be wondering about that deliberate gap running straight down the middle of the board. That's the central channel. It completely splits each horizontal row into 2 unconnected halves. And why is it there? Well, it's so you can straddle a microchip, like a DIP integrated circuit, right across it. Each row of the chip's legs lands in its own set of unconnected holes, giving every single pin an independent connection point without short-circuiting them together. It's pretty brilliant. But listen, even with a solid mental map, it is so easy to get tripped up. Watch out for these incredibly common traps that will stop your circuit dead in its tracks. First, split power rails. On some boards, those long side rails actually break in the middle, meaning you need a little jumper wire to connect the top and bottom halves. Second, don't accidentally put 2 component legs in the same row on opposite sides of that central channel thinking they're connected, because they aren't. Also, keep your wires trimmed. A stray leg bridging 2 columns will absolutely cause a short circuit. And finally, always double check that you haven't mixed up your positive and ground wires. To avoid all those headaches, always start by wiring your power logically and tidily. Picture a 9-volt battery neatly feeding the red and blue rails. Feeding both sides of the board from the very start saves you from so much messy rewiring later on. A great studio best practice is using red wires for connections going to the positive side and black wires for the negative side. Keeping things tidy with short, flat wires isn't just about making it look nice. A logical layout actually lets you trace the circuit by eye so you can find faults instantly. Okay, so now that you know exactly how those underlying metal clips route your electricity, we're ready for the next phase, the components themselves. It's time to start placing the actual functional pieces of your circuit. And there is one passive component you're going to use more than almost anything else. You will absolutely need resistors to keep your LEDs from just popping and to manage the overall voltage in your circuit. Basically, a resistor is a passive component used to limit or control the flow of electrical current, which we measure in ohms. But here's the catch. Because standard through-hole resistors are so tiny, they don't have their values printed on them in numbers. Instead, they communicate their value through a little rainbow of colored stripes circling the body. So when you actually snap one into those connected rows we just talked about, you absolutely have to know its exact resistance value. You really can't just guess, or your circuit won't work, and honestly, you might even fry other components. So we need to learn how to decode these colorful bands quickly and accurately. The absolute crucial point here is reading the resistor from left to right, but you've got to orient it correctly first. Step 1 is holding it so the band with the largest gap is on the far right. This isolated band, which is usually gold or silver, is your tolerance band. That just tells you the allowable deviation from the perfect resistance value. Once it's oriented, step 2 is reading the first 2 bands, which give you your most significant digits. And step 3 is the multiplier band, which simply tells you how many zeros to add to those first 2 digits. Now, if you don't want to constantly pull out a reference chart every single time you build a circuit, you can use this foolproof and slightly weird mnemonic to instantly crack the color code order. It goes like this. Big brown rabbits often yield great big vocal groans when gingerly snapped. I know, it sounds a little silly, but I promise you, committing this phrase to memory will save you hours of looking up charts in the studio. Let's break down how this actually works. You just match the first letter of those words to the colors. Big is black for 0, brown is for 1, rabbits gives us red for 2, often is orange for 3, yield is yellow for 4, great is green for 5. The second big is blue for 6, vocal is violet for 7, groans is gray for 8, when is white for 9, and finally, gingerly snapped reminds us that gold and silver sit at the end for that tolerance gap we talked about. This is a real game changer because it perfectly solves the common problem of mixing up black and brown or green and gray. All right, let's put this into practice. Imagine you pick up a 4-band resistor and you orient that gold tolerance band to the right. Reading left to right, you see yellow, violet, and red. Applying our trick, yield is yellow, which is 4. Vocal is violet, which is 7. That gives us 47. The third band is the multiplier. Rabbits is red, meaning a value of 2. So we literally just add 2 zeros. 47 plus 2 zeros gives us exactly 4,700 ohms, instantly decoded without touching a single chart. So with the hidden mechanics of the breadboard totally demystified, and this foolproof trick for reading resistors safely in your back pocket, the barriers to entry are officially gone. You understand how the power flows, you know how to avoid the common traps, and you can read the components like a total pro. So I have to ask, armed with this new knowledge, what incredible hardware project are you going to build next? Get out there, plug in some components, and start creating.